Okay, welcome back. And here we've got question 12 on this A-level 2023 paper. This is on projectiles. So a small ball P is projected from point A with speed 39, angle theta, and we're told some values of sine and cos, which is always helpful. Point A is 20 meters vertically above point B on horizontal ground. The ball lands at C on horizontal ground. Part A, this is fairly standard. Find the maximum height. So the maximum height is somewhere over here. And what you should be thinking when you see maximum height is that V equals 0 vertically. So for part A, we're going to do a Suvat equation. Okay, so what do we know? Well, we know we're looking for when V equals 0. We want to know the height, which is the displacement. Do we know the initial velocity? Yes, we do. If I resolve this triangle here, I get that the vertical thing is 39 sine theta. Okay, so the initial is 39 sine theta. And we know what sine theta is. It's 5 over 13. Okay, and 39 times 5 over 13 is just 15. Because the 39 divided by the 13 gives us 3. And 3 fives are 15. Finally, we know the acceleration. Oops. We know the acceleration. So the acceleration, we're told in the question to use 10. Because we are resolving upwards, we use negative 10. Okay, brilliant. So, which equation doesn't involve t? Well, that's v squared is u squared plus 2as. So 0 squared is 15 squared plus 2, lots of negative 10, lots of s. And rearranging this, we get that s equals 15 squared divided by 20. Okay, so plugging this into my calculator, let's see what we get. So 15 squared, I think, is 225, divided by 20 gives us 11.25. Okay, so let's just quickly go back to the diagram. What we've shown here is that the distance from A up to the max height, so up to there, is 11.25. But we want the total distance off the ground. The total height off the ground is going to be the 20 plus the 11.25, which is 31.25 meters. Okay, so that's part A done. Okay, part B. The time taken for P to travel from A to C is t seconds. So we know that to get over here, that's t seconds. All right, determine the value of t. So what we need to be thinking about here is, what is the displacement from A to C? Well, it's just going to be negative 20. So again, we're going to do a Suvat. So S-U-V-A-T. We're still resolving upwards because the particle gets projected upwards. So the displacement is negative 20. Okay, like it was before, we had this was 39 sine theta, which was 15. We don't know what the final velocity is now. We still know the acceleration, and we want time. So we don't have v. So which equation doesn't have v? Well, that's s equals ut plus a half at squared. Don't forget these are in the formula book. Okay, now this is the one that gets used the most often, to be honest. So let's see what we get. So negative, why it keeps doing that? So negative 20 is 15t, and then a half of minus 10 is minus 5, and t squared. So rearranging everything, we get 5t squared minus 15t minus 20 is 0. Divide everything by 5, we get t squared minus 3t minus 4. And factorize, we get t minus 4 times t plus 1 is 0. So the only solution here is t is negative 4, because we can't have negative time. Okay, brilliant. So we've shown that it takes 4 seconds for A to basically hit the ground. Okay, part C. This is always a nice straightforward 1 mark. State one limitation of the model other than air resistance or the wind that could affect the answer to part B. Well, the key in this question is we used G equals 10. We could use a more accurate value, because as you should know, G is about 9.81. Okay, fantastic. Let's move on to part D. Okay, so what have we seen so far? Well, we've seen that the maximum height above the ground was 31.25, and we've also seen that T equals 4. So in other words, for the particle to get from A to C was 4 seconds. Okay, part D says there's another particle going to be projected from the ground, and it moves towards C along the horizontal. And this is the formula. V equals kt cubed plus 6t squared plus 3 over 2t. Now, what do we know? Well, we're told that they collide at C, which means they collide after 4 seconds. Because they start at the same time, and we already know that P hits the ground at 4 seconds, and so if they collide at C, then it must be after 4 seconds. Now, what it would be really good to know for this question is, how long does it take, or rather, what's the distance from B to C? And we can do this from P. Okay, so with P, if I look in this direction, we know that speed equals distance over time. So my initial speed was going to be 39 cos theta. The distance is what I'm looking for, and I now know that t equals 4. 39 cos theta is 39 times 12 over 13. I'm going to times this by 4 to get d, and this tells me that d is 144 meters. Okay, so 39 times 12 over 13 is 36, times by 4 is that. This is really good now because what I can do from this equation here, 6t squared plus 3 over 2t, I can now work out the displacement. So to get from here to here, I need to integrate. So we've got kt to the 4 over 4 plus 2t cubed plus 3/4 t squared. There is a plus c, but it should be fairly obvious to see this, but when t equals 0, s is 0. So this means that c is 0. Okay, what do we know now then? Well, we know after 4 seconds, the displacement s is 144. So 144 equals k lots of 4 to the 4 over 4 plus 2 lots of 4 cubed plus 3 over 4 lots of 4 squared, and then plus c. Okay, so 144 equals 4 to the 4 divided by 4 is just 4 cubed, which is 64. 4 cubed is 64, so this is 128. And then 3/4 of 16 is going to be 12. Okay, good. So this implies that 64k equals, this is going to be 4. So then k is going to be 1 over 16. Okay, this is good. Okay, I'll just wipe this off and then we'll write down what we've got. So we've just worked out that k equals 1 over 16. We know that v is now going to be then 1 over 16 t cubed plus 6t squared plus 3 over 2t. Good. So we now want the acceleration of Q immediately before the collision. In other words, we want to work out A when t equals 4. Okay? And I think we have everything we need to do this. To get to A, we need to differentiate. Okay, remember, if you're going from V to A, you differentiate. If you're going from V to S, you integrate. So this differentiates to 3t squared over 16 plus 12t plus 3 over 2. Okay, so when t equals 4, A is 3 lots of 4 squared over 16 plus 12 lots of 4 plus, and then this is 1.5. Just going to make it a little bit easier for myself. Okay, 3 times 16 is 48. Divided by 16 is 3. 12 lots of 4 is 48, plus 1.5, and altogether we get 52.5. And this is meters per second squared. And that there is our final answer. Hope you enjoyed. See you for one more video for the last part of this paper.